At this time, no crystals are visible in the vial. Because of this, I am unable to attest about the number of crystals that have formed or the shape of these crystals. These crystals have not formed yet because of the slow rate of evaporation for the liquid in the vial. The slow rate is intentionally created in order to produce the most perfectly formed crystals as possible. We are slowing the rate of evaporation by placing the kimwipe over the top of the vial, storing the vial in slightly below room temperature conditions, and keeping the vial out of sunlight. If the vial was in sunlight, the temperature of the liquid would be higher, resulting in faster evaporation, resulting in less than optimally formed crystals. I've noticed that the level of the liquid has decreased over time. Additionally, the vial is in an area where it will not be disturbed or knocked over. The theoretical yield for the alum from this experiment is 17.635 grams. This value was calculated by taking the molar mass of an alum crystal, which is 474.3884 grams, and dividing it by the molar mass of aluminum solid, which is 26.9815 grams. This gives us the mass ratio of the alum crystals to aluminum solid. I could then multiply that value by the initial mass of the aluminum foil, which is 1.003 grams, which gives me the theoretical yield of aluminum in this experiment. That value is again 17.635 grams. The experimental alum yield was measured to be 18.787 grams. In order to calculate the percent yield, the theoretical alum yield was subtracted from the experimental alum yield to get the absolute value of the difference between both yields. This number was then divided by the theoretical yield and multiplied 100 in order to get the percent yield. The value of the percent yield was 106.53%. This value means more mass came out of the experiment than the initial mass would indicate had everything gone theoretically perfectly. The only explanation for this result is that there ended up being impurities in the final substance. These impurities could have resulted from suboptimal filtration of ethanol, water, etc., from the aluminum during procedure part 2, or it could have also meant that not all of the solid impurities from the aluminum foil precipitated out of the solution over the course of the entire experiment. Finally, there is a possibility of human error causing suboptimal measuring during the laboratory experiment. Thank you.